Hello and welcome to Geology and Geotechnical Engineering channel. Today I'm going to present the subject Big Bang theory in the coming 20 minutes. In general, there are three theories explaining the formation of the universe. The first one is the Big Bang theory, which is realistic, scientific, and explainable. The second one is steady state theory, which is unrealistic, unscientific, and unexplainable. And the third one is the theory of Anunnakis created by the Sumerians before 4.5 thousand years ago, and their understanding to the universe is myth, unrealistic, and unscientific. The theory of Big Bang is cosmologically explains the formation of the universe, the evolution of space, time, distance, and creation of the matter and antimatter. According to the theory, the universe started to emerge together before 13.8 billion years ago. The universe has been expanding from a trivial atom. The modern particle physics estimates the size of the observable universe to be 93 billion light years in diameter, and 1 light year is a distance parameter which is 9.46 trillion of kilometers. The following are explanations and evidence of the theory. The ancient Greek and Indian developed the cosmological knowledge of Sumerians and Babylonians. Aristarchus Samos believed that the Earth is flat and centralized the universe. Copernicus changed Aristarchus' idea of heliocentric model and proved that the sun is centralizing the solar system. Newton suggested 3 laws of gravitational motion using results from Copernicus, Galilei, Kepler, Tycho Brahe of solar system planet motion. And he suggested 3 laws: the law of inertia, and the law of the movement subject, and the law of the movement of 2 subjects. And 70 years after his death, they found a gravitational unit that can help in the 3rd law to calculate the forces between 2 attracted subjects. The discoveries in early 20th century's science have suggested that the universe had a beginning and that space has been expanding. The first physicist that contributed in this development is Max Planck. He suggested the quantum theory and revolutionized our understanding of atomic and subatomic processes. Alexander Freeman and Georges Lemaitre suggested the theory of the Big Bang. They believe that the universe is expanding in distance from the Earth. The regression of the universe expansion in time and distance will bring us back to the single atom. They call it the primordial atom. Albert Einstein suggested the theory of relativity and the equation of mass energy equivalent, which we are going to use this equivalent equation to prove the Big Bang theory. The special relativity applies to all physical phenomena in the absence of the gravity, and the general relativity explains the law of gravitation and its relation to other forces of the nature. Hubble was studying the red sheds or the red light coming from the particles apart from us, and the Doppler effect, which also suggested to be studied by Einstein. And he also suggested a constant, which is the 73 kilometers per second per megaparsec. 1 parsec is 3,260,000 light years. Thus, he could also calculate how many light years the universe expanded from the primordial atom until our present time. Wien suggested a theory which is a relation between wavelengths of the radiation and the temperature, and also a constant used by Max Planck. So these two equations, we are going to use these two equations to prove the content of the theory of the Big Bang. The chronological development of the Big Bang is resumed in 10 epochs. The first epoch is the blank epoch, which is the earliest stage of the Big Bang. Time equal to blank time, which is 0, approximately more than 3 trillion parts of the second, and the temperature was about 3 trillion Kelvin, which is the radiation temperature. The epoch after that is the grand unification epoch. The time is around 3 trillion parts of the second. Radiation temperature is around 2 trillion Kelvin. The forces, the event happening in this epoch is the forces, fundamental interaction, the electromagnetism, the strong interaction and the weak interaction were unified together to establish a force called the electronuclear force. The epoch after that, which is the electroweak epoch, the time is 1 trillion parts of the second. The radiation is, the temperature radiation is around 1 trillion Kelvin. The temperature of the universe had fallen in this period of time. The Quark Epoch, the time of making 2 up and 1 down quarks, which is the process to establish the first proton and the neutron. The Quark Epoch began about 1 trillion parts of the second, ends at around half parts trillions of the second. The radiation temperature was about 1 trillion Kelvin. In this period of time, the fundamental interaction of gravitation, the electromagnetism, the strong interaction, and the weak interaction forces had taken form in something we call it in the quantum physics the quark plasma. The temperature was high to form and bind the hadrons. The epoch of hadrons, which the time now half trillions parts of the second, the radiation temperature at 1 trillion kelvins had fallen to allow the quarks to bind into hadrons and anti-hadrons pairs, matter and antimatter. Most of it eliminated in annihilation processes. Only light, stable hadrons, photons, and neutrons remains in this period of time. The Photon Epoch is the first, simply is the first from the first second of the explosion to the 10-second of the explosion. The radiation temperature is lower than 1 trillion Kelvin. The neutral lepton and electron or positron charged lepton pairs were created and annihilated at the same time. Temperature was high to produce electrons and positrons parts. The Big Bang nuclear synthesizes, the time is between the first 10 seconds to 1000 seconds of the Big Bang, and the temperature is less than 1 trillion Kelvin. Protons, the evidence happens there is the proton and the neutron are bound into primordial atomic nuclei of hydrogen and helium, trace amount of deuterium, helium-3, and lithium, and the rest of the gases. The photon epoch happens after 370,000 years after the explosion of the Big Bang. The radiation is still lower from 1 trillion Kelvin to around 4,000 Kelvin. In this period of time, the universe contained a hot, dense plasma of electrons and photons. Electromagnetic radiation, such as light, also existed in this epoch, and the lights come from the approach between two positive particles like proton and proton, or two negative particles like electron or electron, to produce energy from that, and that energy is the light. So the photon epoch is the epoch of light comes up from the explosion. The image here is the explosion started here in this area, and then the time began to measure in this direction, and it is still going to this direction. No one can stop the time. The time is moving, and it has the point which is started, and we don't know when it will stop of moving. The recombination time, which is a part of the photon epoch, the radiation temperature was around 4,000 Kelvin. The photons of the cosmic microwave background radiation, which we call it the CBR, originated at this time. There was red shifts or Doppler effects. Universe radius is 42 million light years in this period of time. The Dark Ages started to appear from 370,000 years after the explosion and to around 150 million years after the explosion. The radiation temperature measured to be 60 kelvins. Stars and galaxies began to form after 1 billion to 10 billion years after the first explosion of the Big Bang. The Omega century, the time is 2.3 billion years after the Big Bang explosion, and the Andromeda galaxy began to form after 3.8 billion years after the explosion of the Big Bang, and the Milky Way galaxy began to form after 4.8 billion years of the explosion of the Big Bang, and Alpha century began to form after 7.3 billion years after the Big Bang, and Proxima century began to form after 8.95 billion years, and our solar system and the Earth and the other planet of the solar system began to form after 9.2 billion years, and at that time the temperature of the cosmos fell into between 90 and 60 Kelvin. The sun moves with its planets in an oval orbit once each 226 million of years, and it has moved since then 18 times. The present times is 13.8 billion years after the explosion of the Big Bang. The radiation, the cosmic radiation, has been measured to be 2.7 Kelvin by the satellites we sent it to the space, and the gamma waves, remains wave or residual waves, has also been measured to be around 64 nanometers. We are going to prove that the temperature and the wavelengths the measured by the satellites are approving the theory of the Big Bang. Now we have come to the conclusions for the presentation of today, and I would like to use the equation of mass energy equivalent of Albert Einstein to prove the energy needed for the creation of the first proton and the first electron. This is the equation of the famous equation of Albert Einstein, and according to that, the mass of the proton is given by the particle physics, and the mass of electrons also measured by the particle physics, and the constant of the light velocity, which is the 300,000 kilometers per second, is also given by Albert Einstein. This will help us to calculate the energy needed for the creation of the proton, which is given here, and also the energy needed for creating the electron, which is also given here in this presentation. We are going to use these two numbers to prove the temperatures where the proton and the electron has been created according to the Big Bang theory. And according to the law of displacement suggested by winds, we are going to measure the temperature needed to create the first proton, and we are going to use this number, what we calculated by the Einstein equation, and the result is this amount, which is the temperature, radiation temperature to be existed, and this temperature, under this temperature, the first proton will be created. When we going back to the epochs of the Big Bang theory, we will find this temperature in the epoch suggested by the theory called the Quark Epoch, which is the time of creating the first proton. And this is approved, of course. Using the same equation of wind displacement law here, we calculated the energy or the temperature needed to create the first electron, and this is the temperature in kelvins needed to create the first electron. And if we go back to the Big Bang theory, we will find such temperatures in an epoch called the Proton Epoch, and this is also approved as well. The other conclusion I would like to present today is the near-infrared cosmic background radiation measured by the satellite COPE. The satellite has been sent to the space in 1989 to 1993. In this satellite, the main aim to send this satellite is to measure the background radiations in the space, and also conclude the Big Bang theory. So the wavelengths has been measured there. The minimum wavelength is this one shown here, and if we use when we use the equation of wind displacement law, we can also measure the radiation temperature at the space, which is the 2.7 Kelvin, and this radiation has been also measured by the satellite, and it is indeed the radiation, which is the background from the explosions of the Big Bang. It has been suggested that the universe composes of hydrogen 74%, helium 24%, and other materials around 2%. The temperature of the Big Bang decreases with propagation of the time, and propagation of the time from the first Big Bang explosion produce expansion of the universe. The wavelengths of the radiation decreased with the expansion of the time from long to short wavelengths in lower radiation temperatures. According to the Big Bang theory, the hydrogen atom began to form at a radiation temperature of little lower than 1 trillion Kelvin. Using this radiation temperature in wind displacement law gives that the radiation of the waves of the time of creating the first proton is around 1 trillion parts of the meters, and this radiation is equivalent to the photons epoch. Well, thank you very much for watching this presentation. I would like to say that the Big Bang theory is reasonable, scientific, and explainable also scientifically. My name is Sabah. I am an engineer geologist, and my next presentation will deal with the formation of the solar system. Thanks again for watching this video, and take care.